Welcome back for lesson 1.5a, or the first half of it. We're going to transition into solving inequalities now. We've taken care of talking about equations. Now let's talk about inequalities. So our learning target for today is you're going to be able to graph and solve inequalities. So to review what these look like, we're going to talk about what they look like in words and then graphing. So this first one, how would we say that? Well, we would say x is less than 2. That's how we would say it in words. Now, graphically, what are we talking about? Well, if that's 0, 1, 2, remember, strictly less than, we're talking about an open circle. Less than is everything to the left. So note the open circle, and the less than means everything to the left. All right, now one quick little trick is realizing the arrow at the end matches the arrow of the inequality. So that's one little quick check to make sure that you've done it right, is those should match. All right, our next one. X is greater than or equal to 5. So that's how we would express that one in words. Now, what does it look like in terms of the graph? Well, if there's 0, 1, 2, 3, 4, 5. Well, remember graphically, that or equal to piece makes it a solid circle because it could actually be 5. And anything greater than it is going to be pointing in that direction. And again, really quick check. And yes, that matches. All right. So here x is greater than 3. That's going to be our next phrase. What does that look like? Well, we're back to dealing with strictly greater than, okay? It can't actually be 3, it can only be greater than 3. So that means we have the open circle. Greater than still goes to the right. And again, quick check. My arrow matches my inequality sign. So that means I've set it up properly. Finally, how would we say this? Well, we would say x is less than or equal to, what do I have there? A negative 1. All right, that or equal to means it could actually be negative 1. Because it could actually be that value, we're going to shade it in. We're going to have a solid circle there. Less than, it's going to be going in that direction off to the left. And again, just quick check, your arrow should match the direction of the inequality. Which is a nice segue into the next one, because notice that one's backwards from what we've done so far, isn't it? We don't really usually think of the variable being on the right in this case. It's much easier to read it if it's on the left. So what I'm going to say to do in this case, just to simplify it for yourself, is switch the variables, okay? Switch the sides, remembering that that also switches the inequality, okay? Everything switches. If you switch the sides of the inequality, you switch the inequality itself. And once you've done that, now you can solve it just like you did the other ones. So x is less than or equal to 4. 1, 2, 3, 4. or equal to means it could actually be 4. So I'm going to make it a solid dot less than. And then again, really quick check, does my arrow match the direction of my inequality? Because I switched it the way that I wrote it, yes, it does. All right, now, as we transition into these word problems, I'm going to come back to that chart, okay? Because there is some other vocabulary. The way that I worded it there is the way you will most commonly write it if you tried it yourself. But think about this scenario. The product of 7 and a number is no more than 50. No more than, okay? So we have product of 7 and a number, so that's going to be simple. We're comparing it to 50. So I want you to consider, could it be less than 50? So for example, is 40 no more than 50? The answer is yes. So we're dealing with less than, okay? No more than. However, could it actually be 50? And the answer is yes. 50 is no more than 50. So you do actually want to include the or equal to down there. So I want you to add to this example up here, the less than or equal to, I want you to add no more than is another example of how you could phrase that. Okay, because it could be anything less than it or equal to it. So when you have that other vocabulary, you do have to think a little bit harder about what it's trying to communicate to you. What about this one? The quotient of a number and 3. Well, the quotient of a number and 3 is going to be n divided by 3 is at least 15. So at least, to me, that's saying it could be greater than it. So is 16 at least 15? Well, yeah. So is 17. So is 18. So is 19. So we're talking about being greater than 15. Is 15 at least 15? The answer is yes. We are talking about the situation again where it can be or equal to. So I do want you to go and add that vocabulary up there for me as well. At least is another phrase that will indicate that scenario. All right, so I do want you to keep that in mind. I want you to have those extra words there because if those come up, I want to make sure you're making the correct inequalities. So now that we have the vocabulary down and the basics down, let's talk about one other thing that can complicate these. And the thing that can complicate it is, remember, if you multiply or divide by a negative, I want you to recall that means you have to flip the direction of the inequality, okay? You have to reverse the inequality. But again, only if you're multiplying and dividing by a negative. All right, so let's take a look at what that looks like. So in this first case, the first thing that comes to mind, I see those parentheses, I am going to distribute. So I have 4x minus 28 is greater than negative 20. All right, now again, just like when we're doing equations, we're going to take the same steps to solve inequalities. So I'm going to deal with the addition and subtraction first. So I'm going to add 28 to both sides. So 4x is greater than, well, negative 20 plus 28 is going to just leave me with 8. And then, looking at this, next step, I have to divide by 4. So x is going to be greater than 2. So there's my inequality. Now, it also wants me to graph my solution. So let's see what this looks like graphically. So there's my 2. So x being greater than 2, Well, greater than means it can't actually be 2. So I'm going to leave an open circle to represent that. And then greater than is off to the right. And again, really quick check. Did I draw it correctly? Well, my arrow matches my inequality, so I am good to go. So let's look at our next one. So again, I see something that can be distributed. So that's going to be my first step. So negative 2x minus 18 plus 5 is greater than or equal to 3. Now, I still see some like terms that I can combine. I can take that negative 18, I can add the 5 to it. Those are like terms. So I'm going to combine those two. Now, once again, we are talking about solving an inequality just like how we solve equations. So what that means, same order for the process. So I'm going to take care of that subtraction first. So I'm going to add 13 to both sides. So negative 2x is greater than or equal to 16. Now I want you to notice x is being multiplied by negative 2. So that means to get x alone, I'm going to have to divide by negative 2. Now keep in mind here we have x, we have negative 8. I just divided by a negative number. And remember that rule that we just talked about. If you multiply or divide by a negative, remember you have to flip the direction of the inequality. So you're going to have to flip it the other direction. Okay, that is essential to getting these right. Remember that flipping process. 1, 2, 3. Oh, I'm sorry. I'm doing that in the wrong direction. Put my 0 up here. 1, 2, 3, 4, 5, 6, 7, 8. Less than or equal to means I'm getting a solid. And then off to the left. And again, really quick check. Does my arrow match my inequality? Yes, it does. All right. So let's take a look at what this looks like in word problem form. So plumber A charges $75 for a service charge and $40 per hour. Plumber B charges $50 per hour, but there's no service charge. How many hours must a plumbing job last for plumber A to cost less than plumber B? All right. So let's take a look at this. So in order to compare their prices, we're going to want to write an expression for each of them. So let's write an expression for plumber A. So to represent the cost for plumber A, they have a $75 charge. All right, so $75 no matter what, just service fee. And then they only charge $40 per hour. So $40 for every hour. Remember how we represent that. All right, and again, letting H represent the number of hours. Plumber B. Plumber B, there is no service charges, okay? No service charge, just flat $50 per hour. All right, so here, $50 per hour without a service fee. All right, and now we want plumber A to cost less than plumber B. So I'm going to write this 75 plus 48. We want to know for what values will that be less than plumber B. So when they charge 50H. All right, so I have my expressions written. Now I'm going to solve the inequality. So I notice I have my variable on both sides. So I'm going to subtract off that 40H to get my variable to one side. All right, and now finally to get the h by itself, I can divide by that 10. So the answer to the question is, if your job takes more than 7.5 hours, so H is greater than 7.5 hours, plumber A is going to be cheaper. All right, so again, not too complicated, just being able to write the words and then transform that into an inequality to solve. So let's jump ahead to our next example. So digital music service offers two subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee but only charges 50 cents per download. How many songs must you download for the second plan to cost less than the first plan? So let's represent plan 1, okay? So a $9 membership fee, so just flat fee, $9, and then $1 per download. So $1 for every download. What does the second plan do? Well, the second plan has a $25 membership fee, much higher one, but it only charges you $0.5 per download. So D obviously representing the number of downloads in this case. And what we want to know when is the second plan less than the first? Okay, so we want the second plan less than the first. So that means that it's opening up to the plan that's more expensive. So when the first plan is more expensive, remember that's how it opens, to the more expensive thing. And now we simply solve. So I notice my variable is on both sides. So that's the first thing I'm going to take care of. So I'm going to subtract 5 or 0.5d. Oh, I'm sorry, I wrote that awkwardly over here. I'm going to subtract off 0.5d from both sides. Well, 1 minus 0.5 is 0.5. Well, now I just have to get that 9 away from my variable, okay? Recall, you do addition and subtraction before multiplication and division. So I'm going to subtract that 9 off. I don't want that 9 there. So 0.5d is greater than 25 minus 9 gives me 16. So I've taken care of the addition and subtraction. Now I can take care of multiplication and division. So 0.5 is multiplying my d. So that means I want to divide by 0.5. So I divide by 0.5. 16 divided by 0.5 gives me 32. So if you buy over 32 songs, you download over 32 songs, that second plan is going to be cheaper than the first plan. And the last concept I want to cover with you is, just like when the variable cancels out of equations, there's two special cases. Well, those same two special cases apply to inequalities. You can either have no solution or all real numbers. All right, so let's take a look at what that looks like in this instance. So I'm going to do my distributing. So 3x plus 9 is going to equal to 6 plus 3x. And again, I notice that my variable is on both sides of my equation, so the first thing I'm going to do is try to fix that. So subtract 3x, to attempt to cancel it over here, but notice it also cancels over there. So what do we get? Well, we get 9 is greater than or equal to 6. So what that means is every x is a solution to this inequality. You're left with something that's true. 9 is always going to be greater than or equal to 6. So because this is always true, what that means is every real number, all real numbers, are a solution to this inequality. All right, what about the flip side, the other example? Well, I'm going to combine my like terms first. So 9 minus 5 gives me 4. All right, and again, I see that my variables on both sides of the equation. So to try to cancel it off at this side, I'm going to add that x to both sides. But again, it doesn't quite work. All right, so my variable cancels off of both sides. And I'm left with 4 is less than 4. Now, this is a tricky one. I want you to really think about this. Is 4 less than 4? And the answer is no. No, it's not. Okay, 4 is equal to 4, but a number can't be less than itself. So this is an instance you're left with something that is not true. You're left with something that's nonsense. So this is going to be a no solution case. Okay, there is no x that will make that inequality true. It will never, ever be true. All right, so hopefully you can see how that mirrors the equations that we solved. So, final thing, as always, I want you to take a few moments here and write a summary or write about something that you're still curious about from this note video, and then we will discuss those in class.